The universe, with its vast expanse of galaxies, stars, and mysteries, has always captivated our imagination. One of its most confounding elements is dark energy. What is it, and how will it shape the destiny of our universe as we approach the end of time? Let's find out. Despite its name, dark energy is neither dark nor made of matter. It's called dark because it doesn't interact with light or any other part of the electromagnetic spectrum, making it invisible to our current technology. So, how do we know it exists? The evidence comes from how it appears to impact our expanding universe. At the beginning of time, the universe was born from the Big Bang and has been growing ever since. Think of it like a giant balloon that gets bigger and bigger as it's inflated. Then in the 1920s, Edwin Hubble proved this by observing that galaxies were moving away in every direction. It was the moment he realized that the universe was expanding. However, the real surprise came in the late 1990s. At the time, it was thought that gravity would eventually slow the expansion. But astronomers studying distant supernovae found that the rate of expansion was accelerating, not slowing down. Standard physics is unable to explain this. Can it be that there's some unknown energy working against gravity? This mysterious force was named dark energy. What it is remains one of the biggest unsolved puzzles in cosmology. Even more surprising, along with this new mystery came a revelation, and that is that all the visible matter we see, stars, planets, galaxies, everything you've ever known, seen, or touched makes up only about 5% of the universe. That's right, just 5%. The vastness of the galaxy, the brilliance of stars, the complexity of life on Earth, all of it is just a tiny fraction of what's really out there. The remaining 95% is a cosmic puzzle, and most of this puzzle is made up of dark energy. It's as if the universe is hiding its true nature from us, with this energy being its most profound secret. But it isn't just a passive player in this cosmic drama. It's actively shaping the universe's destiny. Dark energy is now accelerating the expansion of space. Put another way, the balloon we talked about earlier is inflating faster than we thought. If dark energy continues to strengthen, what does this mean for the universe's destiny? Historically, astronomers debated about two possible endings: the Big Crunch and the Heat Death or Big Freeze. In the Big Crunch scenario, the gravitational attraction of all matter eventually overcomes the force of expansion. Let's go back to our balloon analogy. In this scenario, instead of expanding indefinitely, the balloon reaches a point where it stops getting bigger and begins to shrink. As the universe contracts, galaxies would start moving closer together, reversing the trend of drifting apart. The night sky would become a dazzling display of merging galaxies. Over time, the contraction would begin to speed up, and the universe would become hotter and denser. Stars would collide and merge, creating new cosmic structures. The fundamental forces of nature would be forcibly combined, altering the very fabric of reality. Eventually, the universe would collapse into a singularity, a point of infinite density and temperature. This would mirror the initial conditions of the Big Bang, but in reverse. The Big Crunch paints a picture of a cyclical cosmos, where the end is also the beginning. In the distant future, the remnants of our universe may lead to another Big Bang, giving birth to another one in a never-ending cycle of creation and destruction. That was the prominent theory for decades, but not anymore. Instead, the Big Freeze scenario is our likely fate. In this outcome, the universe's expansion continues indefinitely. As billions of years turn into trillions, the universe slowly fades away into a dark, empty, endless void. Galaxies, once vibrant with the birth and death of stars, will see fewer of them forming. Over time, these galaxies will merge, forming supergalaxies only to drift apart again, becoming increasingly isolated in the vastness of space. Stars will exhaust their nuclear fuel, and the night sky, once ablaze with their light, will darken. Humanity would have long ago evolved, perhaps merging with advanced AI or branching into various species adapted to new environments on other planets. Alien civilizations that might have spanned galaxies would have risen and fallen, leaving only traces of their existence behind. The universe will become a much quieter place. The chaotic activity of galaxies colliding and stars forming will be rare events. Black holes, the last remnants of massive stars, will dominate, slowly consuming any remaining matter. Yet, even these cosmic behemoths are not eternal. Given enough time, they too will evaporate due to Hawking radiation, releasing their energy back into the universe. In this vast, cold, and dark universe, the concept of time will lose meaning. Without significant events to mark its passage, time becomes just another dimension, much like space. But let's not get ahead of ourselves. Humanity still dominates our corner of the galaxy, and we have plenty of things to do before we fade away. Soon, new experiments to study dark energy will begin. For example, the Dark Energy Spectroscopic Instrument will create a 3D map of the universe. These sophisticated maps will help us learn how dark energy accelerates the universe's expansion. Next, the Euclid Space Telescope, developed by the European Space Agency and launched in 2023, is set to map the universe in unprecedented detail. By observing billions of galaxies through a 600-megapixel camera, Euclid will reveal how the universe has expanded and how its structure has formed over time. We're standing on the brink of new discoveries. How do you think dark energy will impact the evolution of our universe? Share your thoughts in the comments below, and let's continue this journey through the universe together. Thanks for joining us. If you're still watching, please like, share, and subscribe. Until the next time.